A is called the lower limit and B is called the upper limit of a function. That is, we have to find the integral value. If you add all these rectangles, you will get the total area bounded by the region. So this is what the limit of a sum says. The definite integrals denotes the area bounded by the curve with the x-axis along with the ordinates from x is equal to a to x is equal to b. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysore. In this section, we are going to discuss definite integral. So what do you mean by definite integral? So definite integral of any function is a unique value and it is denoted by integral from b to a or sometimes from a to b f of x dx. So this is called as the lower limit and this is called as the upper limit of f of x. So sometimes it can also be denoted as a to b f of x dx, where a is called the lower limit and b is called the upper limit of a function. That is, we have to find the integral value. And geometrically, definite integral is nothing but the area under the curve. Suppose we have any curve in the x-axis and y-axis. If this is the curve here, the area under this curve with the coordinates a and b. So usually that is the area covered by this curve below it and above the x-axis and between the ordinates a and b is nothing but the definite integral. So geometrically, definite integral is nothing but the area under the curves with respect to the ordinates x-axis, and symbolically we denote it as integral from a to b f of x dx or integral from b to a f of x dx. Algebraically, definite integrals can be discussed in two ways. One is the limit of a sum and the other one is the fundamental theorem of calculus. Let's discuss about what is the limit of a sum as well as what is the fundamental theorem of calculus states in accordance with the definite integral. So let's see the limit of a sum with respect to the definite integrals. Now here, we know that let f be a continuous function defined on a closed interval a comma b. I have already said to you a continuous function is always inside the closed interval so that we can define the value a and b. So therefore, f be a continuous function on the closed interval a comma b and the definite integral is nothing but the area bounded by the curve y is equal to f of x and the ordinate x is equal to a, x is equal to b and the x-axis. Now let me take a curve y is equal to f of x whose all values are non-negative. Then obviously the curve should be on the positive side of the x-axis. So let a denote the first limit and b denote the second limit of this continuous function here. So now what I will do is, we have an interval from a comma b. Divide these interval from x0, x1, x2, xr minus 1, xr until the last limit we take it as xn. So until this each limit, divide the curve into small rectangles. Now what we are going to calculate here, within this limits or within this intervals here, we are going to calculate the area of each small rectangles, and when you sum of all rectangles you will get the total area bounded by this curve. This is what the definite integral says. So here, as the limit of a sum, we will divide each interval with respect to the small sub-intervals, that is from x0 to x1, x1 to x2, it goes on, xr minus 1 to xr, then again it goes on until the last limit. So we will take the first one as a and the second one as b, and we will sum up each rectangles. So that is where we'll define a function. We'll apply the limit as n tends to infinity. So here, y I have taken, we can take x0 is equal to a, x1 can be taken as a plus h, x2 can be taken as a plus 2h And similarly, xn can be taken as a plus nh, where xn is the value of b. So now here, if each interval is in this form, if you take the limit of this sum, then each limit, adding all the limits, we will get the total area bounded by this region. That is why I have taken here limit as n tends to infinity, f of a plus h, f of a plus 2h, until f of plus rh, until f of a plus n minus 1 into h, which is the last interval. Here h is nothing but b minus a divided by n. So using this result, you will get what is h. So h is nothing but b minus a divided by n, that is upper limit minus lower limit divided by n. Or if you subtract the end points of intervals divided by n, you will get the h. Now clearly we can see as n tends to infinity, h tends to 0. That's why if you add all these rectangles, you will get the total area bounded by the region. So this is what the limit of a sum says. So that is, definite integrals can be represented as a limit of a sum, which is nothing but adding all the intervals by finding the area of a small rectangles, so that when you add each rectangles, here you will get the total area bounded by the curve y is equal to f of x. Now using this definition, let us evaluate the definite integrals of few functions. So let us take the first one, evaluate integral from 0 to 2 e power x dx as a limit of a sum. What does the limit of a sum definition says? That is integral from a to b f of x dx can be written as h can be replaced as b minus a by n. So therefore I can take it as b minus a, limit as n tends to infinity, h here f of a plus f of a plus h plus f of a plus 2h plus etc. f of a plus n minus 1 into h. So this is what the definition of the limit of a sum says. Now here according to this, we have a is equal to 0, b is equal to 2, f of x is nothing but e power x. Now what is h? h is equal to b minus a divided by n. Now we know b, it is 2 minus 0, which is 2 minus 0, which becomes 2. So therefore h value is 2 by n. Now express this, we have integral from 0 to 2 e power x dx. So b minus a means 2 minus 0, which becomes 2, limit as n tends to infinity. So the first one, f of a value is 0, so therefore it is e power 0. Because f of x has to be expressed in e power x. f of a plus h. So a plus h means 0 plus h. So in the place of x you have h. What is h? It is 2 by n. Next plus a plus 2h means 0 plus 2h, which means in the place of x you have 2h. So therefore if you write this as e power x, 2h is nothing but 2 into 2 by n, which becomes 4 by n. And it goes on where it becomes n minus 1 by h. So therefore the last limit becomes e power 2n minus 2 divided by n. So now look here, this is of the form of geometric series where 0, 2 by n, 4 by n, next you will get like 2h, 3h means it will be obviously 6 by n, and the last one is 2 into n minus 1 by n, which is nothing but 2n minus 2 by 2. Now applying GP for this series, we get here 2 into, so here we have limit n tends to infinity. So here we have 1 divided by n. So in the place of h we need to write 1 by n. So this can be written as e to the power 2n minus n minus 1 divided by e power 2 by n minus 1. Now next here, n get cancels in the numerator. Apply the limit for both numerator and denominator separately. So then we have 2 times. So here the numerator becomes e square. So e square minus 1 divided by limit as n tends to infinity e to the power 2 by n. I will take 1 by n to the denominator. So I'll write 1 by n here. So next what I will do here, I'll multiply 2 and I'll divide by 2 here, so that this is minus 1 now. We know that limit as h tends to 0, e power h minus 1 divided by h is equal to 1, which is a standard limit. So therefore this is in the form of e power 2 by n minus 1 into 2. Now here in the numerator 2 and 2 get cancelled. So this can be equal to 1. So therefore this is e square minus 1. So therefore integral from 0 to 2 e power x dx can be written in the form of e square minus 1. So this is the integral value of the limit of the sum, and this is the area bounded by the curve 0 to 2 e power x dx. Next is evaluate 0 to 2 x square plus 1 dx as a limit of a sum. Let us write the definition. So integral from a to b f of x dx can be written as b minus a limit as n tends to 0, 1 by n into f of a plus f of a plus h plus f of a plus 2h plus etc. f of a plus n minus 1 into h. So now if you apply here 0 to 2, again it becomes 2, limit as n tends to 0, 1 by n. So here it is f of 0 plus h is what? That is 2 by n, f of 2 by n plus f of 4 by n plus etc. plus f of 0 plus h is 2 into n minus 1 divided by n. So now we need to express in this form. So therefore this is 2 times limit as n tends to 0, 1 by n into f of 0 means it is 1 plus f of 2 by n. So therefore it is 2 by n means it is 2 square by n square plus 1. Next is this is 4 by n. So therefore it is 4 square by n square plus 1 plus etc. So here it is again 2 square, or we can write it as 2n minus 2 whole square divided by n square plus 1. So this is how we are going to express. Now here 1 is repeated n times. So therefore if you add 1, so 2 into limit as n tends to 0. So here we can take 1 plus 1 plus 1 plus 1. So how many times here we have? We have here n times. And here if you separate n, so here we can take 2 square by n square plus 4 square by n square plus etc. plus 2n minus 2 whole square divided by n square. So this is another form we can take. So now here 1 plus 1 plus 1 plus 1 n times. So next we are going to write here 2 into limit as n tends to 0. Since 1 is repeated n times, we can take n as a common factor. Observe here n square is common in the denominator. Take out. So we have n square in the denominator. Also we have 2 square as a common factor in the numerator. Take it outside. So if you take it outside, we will get 1 square plus 2 square plus etc. until n minus 1 whole square. So now this is a series, a sum of a series. So if you apply sum of this series, this is 2 into limit as n tends to 0, n plus this is n into n minus 1, 2n minus 1 divided by 6. So this is what we'll get. So next is, so here we have left 1 by n, write 1 by n here. So write 1 by n here also. So taking here 2 square is nothing but 4, and here we have n square. So n get cancelled. 2's are 2 3's are get cancelled. So next I have 2 times limit as n tends to infinity 1 by n into n plus 2 by 3 n minus 1 2n minus 1. So multiply n to the inside value. So then it becomes n over n 1 plus 2 by 3. So this becomes 1 minus 1 by n. Next 2 minus 1 by n. Now let us apply the limit as n tends to 0. So if you apply limit as n tends to 0 here, so then here it is 2 into 1 plus 2 by 3. 1 by 0, it is 0. So therefore it is 1. Next here, again we will get 2. So 2 2's are 4, 4 by 3. So next here we have 2 into 1 plus 4 by 3. So next it becomes 7 by 3. So the value finally it becomes 14 by 3. So therefore 14 by 3 is the value of this result. That is integral from 0 to 2 x square plus 1 dx. That is integral from 0 to 2 x square plus 1 dx, whose value is 14 by 3. If you consider this as area, then it is 14 by 3 square units. Thus, the definite integrals denotes the area bounded by the curve with the x-axis along with the ordinates from x is equal to a to x is equal to b. Next, we have fundamental theorem of calculus. So, fundamental theorem of calculus, first we will study area function. So, what is this area function? So, let me take a curve here. So, this is a curve. So, let me take A and B as an interval. Let x be any point belongs to the interval, closed interval A comma B. Then, integral from A to x, f of x dx. That is nothing but the area shaded here. It denotes the area from the interval a to x, which is denoted by interval a to x f of x dx. So this is called as the area function, where x belongs to any interval where x belongs to the closed interval a comma b. Thus, area function is nothing but the area shaded by the region from a to x, where x belongs to closed interval a comma b. Next is first fundamental theorem of integral calculus. What does it state? Let f be a continuous function on the closed interval a comma b, and let a of x be the area function. So we know that area of function is nothing but it's a area from the interval a to x, or the area bounded by the curve from limit a to x. Okay, then a dash of x is equal to f of x for all x belongs to a comma b. That is the derivative of this function, area function, which gives you the f of x for all x belongs to the closed interval a comma b. So that is what the first fundamental theorem of calculus says. Let's see the second fundamental theorem of integral calculus. So here, let f be a continuous function on the closed interval a comma b, then f be an antiderivative of f. Antiderivative is nothing but the integral value of the given function, and any function from a to b f of x dx is defined as f of x to a to b, which is nothing but f of b minus f of a, where b represents the upper limit and a represents the lower limit. Thus, f of b represents the value of the antiderivative at b, and f of a denotes the value of the antiderivative of a, that is at point a. So we have taken an example, integral from 0 to 2 x square plus 1 dx. What we have got the values using the limit of a sum 14 by 3. So let's see this method now. So this is nothing but find the integral of this function, which is x cube by 3 plus x, and we need to find the value at 0 as well as 2. According to the second fundamental theorem of integral calculus, we need to find the value of upper limit first and then lower limit, and then take the difference. So finding the upper limit now, 2 cube by 3, which becomes 8 by 3 plus 2, minus here we have 0 by 3 plus 0. So the second one is completely 0 here. This is completely 0. So 3 2s are 6, 8 plus 6, 14. So the value is 14 by 3. So thus, the fundamental theorem of integral calculus, or the second fundamental theorem of integral calculus, is very easy to calculate when compared to the limit of a sum. So this also builds a strong relationship between the differentiation as well as integration. Hence, this method is more useful in finding the definite integral as comparable to the limit of a sum. Even though they will give you the same limit, this is very time limited and easiest method to find the definite integral values. Thus, the second fundamental theorem of integral calculus says, find the integral value, apply the upper limit and lower limit, find the value of the antiderivative at b as well as a, take their difference, you will get the definite integral value, or which is nothing but the value of the required area. Now let's take few examples. Try to solve using second fundamental theorem of integral calculus. So here we have, find the integral value from 2 to 3 of the function 1 by x dx. We know that integral of 1 by x is nothing but log x. Now let us apply, or let us find the value at 3 and 2. What is the value? It is log 3 minus log 2. So finding the values, you will get the simple value. You can write the log 3, log 2 value and then subtract it. So this is the value of the given function. Thus, definite integral is nothing but a unique value. You have to find out the unique value of each function, which is exactly a numerical value. Next one, 0 to pi by 4 tan x dx. So we know that the integral value of tan x is log of secant x. Now we need to find out the value at 0 as well as pi by 4. So what does the fundamental theorem says? So that is, find out the upper limit value, that is log of secant of pi by 4 and minus log of secant 0. So what is the value of secant pi by 4? So we know that cos pi by 4 is 1 by root 2. So therefore secant pi by 4 is root 2. So therefore it becomes log of root 2. Next here, what is cos 0? So cos 0 is 1. So what is secant 0? Secant 0 is also 1. So minus log 1. We know that value of log 1 is 0. So therefore this can be written as log root 2. So this is the value of the given integral. Next, integral from 0 to pi by 2 cos 2x dx. We know that integral of any function of the form f of ax plus b with respect to dx can be written as 1 by a f of ax plus b, where f of ax plus b is the antiderivative of the function and ax plus b, since constants are given, that has to be written in the form of 1 by a. Now, what is the integral value of cos x? So cos x is sin x. So therefore here I can write this as 1 by 2 times sin 2x, because antiderivative of cos is sin, and since this is in the form of ax plus b, I have to write 1 by a here. So now let me apply the limits from 0 to pi by 2. So let me take half outside because it's a constant. So now let me apply the limits for sin 2x, 0 to pi by 2. So half. So when you take pi by 2 here, 2 get cancelled. This becomes a sin pi minus sin 0. So what is the value of sin any pi? It is 0. What is the value of sin 0? It is 0. So 0 into half is 0. Thus, the value of this definite integral is 0. So this is how we are going to calculate the value of the definite integral using the second theorem of fundamental calculus. So let's take up few more problems in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.